you go back, alright, so what we'll do today is, you guys are doing the recent two labs, last lab and the one before that, especially the last lab. You looked at system responses. With additional poles and additional zeros. So what you did was, you took a system in your lab, you added a zero to it, you added a pole to it, and looked at the response of that system, of the two systems. Okay. So for example, consider this. Case 1, you have two poles here, 1, 2, P1, P2, and P3. Okay. This is sigma, this is j omega, this is S plane, right? Case 2. case 3 where if you plot the responses of these three systems on a single plot, see what's going to happen is, take you plot this, have see, just by varying, what you need to understand here is, this is 0, let's say this is 1, your C of t is this, and this is the time axis. So just by varying the poles, see if you just move the pole away, this would be case 1, this would be case 2, and this would be case 3. Okay. So what you need to understand here is, and you have done this exercise as part of your lab, you took 3 systems and you added a pole and plotted. You moved the pole, you kept moving the pole away from the origin. So here you need to understand these two are the dominant poles. This is the non-dominant pole. So when you move the non-dominant pole, it doesn't have significant effect. So you see case 1 and look at the difference between case 1 and case 2. Case 1 and case 2 are pretty different. The response is pretty different. So this is case 1, right? And this is case 2. But when you, between case 2 and case 3, the response is not very different, because what you're trying to do here is, this pole has been moved really far off from the origin. This is a non-dominant pole. If you take this off, it's not going to alter the response much. Still, the response is largely going to be dictated by these dominant poles. Okay? And similarly, when you're if you look at the responses of system with multiple zeros or different, you're adding zeros. Okay? So what you're going to do is, here is, when you add zeros, this could be case 1, case 2, and this is case 3. Okay. So again, here what you're seeing here is so differences between case 1, case 2, and case 3. The systems have varying fields. Okay. So this one, let's say, has 0 at -3, 0 at -5, and this one has 0 at -10, something like that. Okay. -3, -5, and so when you have zeros, when you add zeros, you can change the rise time of these various systems. You can alter some of the characteristics. Now, when you're designing your systems, these are some of the parameters to which you are required to design. As control engineers, you'll be required to show that the system achieves a particular characteristic, particular lifetime, particular settling time, and all those things. So this case 2 and case 3. Right. It's see, what happens is you should actually take a look at it like this. This may look like this. So the rise time is different. Something like this. I will refer you to the figure. Actually, that would be better. You can read about this in figure 4.25. And really, this is for you have already done the lab exercise, and I think you should, one of your objectives of doing the lab is to derive conclusions about these various systems. So what does adding pole do to the system? What does adding zero do to the system? And you need to go back and see how the second order systems get affected by adding poles and zeros. Okay. So this completes chapter 4. We'll move on to chapter 5, which is block diagram reduction. Okay. Block diagram reduction and signal flow graphs. I'm just going to erase this part. So we're going to start with chapter 5, which is reduction of So when you're looking at it, we'll also commonly refer to this as block diagram reduction. Okay, don't get confused when you hear the word block diagram reduction. There are three basic forms of basic types. The first one is cascade form. The second one is parallel form. And the third one is feedback form. And all three by themselves are pretty simple actually, but when you're given a complex block, that's when things start becoming a little complicated. Okay, so cascade form is very simple. If you have a block diagram written like this, you have G1 of this, G2 of S, and so you have R of S, and this is C of S. Okay. So your goal here, in all these block diagram reductions, you will be asked to find, the question would be something like this. What is C of S over R of S? What is the transfer function which will combine these blocks and give you one transfer function? So if you look at this, it's fairly simple. So let's say this output is x1 of S, and let's say this x output is x2 of S. So what is x1 of s over r of s? It is g1 of s. Okay. Similarly, x2 of s over x1 of s is equal to g2 of s. And finally, c of s over x2 of s is equal to g3 of s, right? And what you have been asked to do is you're supposed to figure out c of s over r of s, right? So what do? You do c of s over x2 of s into x2 of s over x1 of s into x1 of s over r of s, right? So this is what g3 of s, g2 of s, g1 of s, right? So you can say, you can just cancel this off, right? So what you're going to get here is c of s over r of s is equal to g1 of s, g2 of s into g3 of s. Okay? So as a combined block, this is how you're going to write. G1 of s, G2 of s, G3 of s. This is C of s, this is R of s. Okay. The second form is parallel form. Parallel form is something like this. You have G1 of s, G2 of s, and these go into a summation block. Okay. So what do you have? It could be plus minus, plus minus, or plus minus. And again, your question would be something like this. What is C of s over R of s? Okay. So in this case, your C of s over R of s would be equal to G1 of s plus or minus G2 of s plus or minus G3 of s. Okay. So if you were to write your reduced block diagram, you would write it like this. G1 of s plus or minus G2 of s minus G3 of s. Now you can do similar math with the block diagram. Okay, you can. I'll leave it up to you to do the math. The final one is the feedback form. Looking at feedback form, G of S. Alright, now I want you guys to pay attention with this one. This is slightly challenging, okay? And you're going to encounter this a lot. So please pay some attention. So the way you're going to go about doing this is, you're going to, if you're given such a block, the first thing you're going to introduce is an error signal, okay? E of S. Error signal, yes. Now if I do that, see what's going to happen here is, I have this, H of S. Have I changed anything out here? Your question again would be very similar. Question would be, what is T of S which is equal to output over input? Your question would always be to figure out the transfer function. For a feedback form, we use T of S. For an open loop, we use G of S. Okay. So if you compare this one and this one, did I change anything out here? Right. So I've just separated. See, this what signal is going in here? The C of S is going, right? I've just introduced another C of S going in. Okay. So what is E of S? What is my E of S? E of S is R of S plus or minus C of S into H of S. You agree? This is my E of S. Now, what is C of S over E of S? This is G of S. Right? C of S over E of S is? It's G of S. Okay? what I'm going to do is I'm going to replace this E of S with this. Okay? So C of S over R of S plus or minus C of S H of S is equal to G of S. Okay? And if I do that, I'm going to get C of S is equal to R of S G of S plus or minus G of S C of S H of S. Okay. What do I need? I need, keep this in mind, this is your objective. Okay, this is very important. I need C of S, right? So what I'm going to do is, now C of S minus plus G of S, C of S, H of S is equal to R of S into G of S. Okay. What I've done is I've moved this from right hand side to the left hand side. So plus minus becomes minus plus. Okay. So I'm going to take out C of S, common, 1 minus plus G of S, H of S is equal to R of S into G of S. Okay. So if I move R of S on this side and this on the other side, what I'm going to get is C of S over R of S is equal to G of S over 1 minus plus G of S H of S. Okay. So this is a feedback form. So if you start with this, essentially what you need to remember, one of the things you need to remember is, if this is plus, it ends up a minus here. If it is minus, it ends up as a plus. Okay, and you may encounter a case where, so if you have something like this, so what is this? Compare this to this. This is a unity feedback system, which means H of S is 1. Okay. So all you need to do is, if you're given such a system, replace H of S by 1. Huh? See, if there is no feedback, then it's an open system. Okay. That's what your question is, right? So if there is no feedback, there's an open system. Most of our control systems are closed loop systems. Can you think of a open control system? Can you think of a practical control system in your everyday life? A very simple control system. Huh? That's not a control system. What is a control system? Air conditioner is a control system, right? So what are you controlling? The temperature, right? So what you're doing is, this is the temperature, right? And what you're supplying is, let's say, some current or some voltage to that system. This is your, this is the plant, your house, and the air conditioning system together. You can think about it like this. Okay. So you have the temperature, right? Now the temperature is transduced. Electrical systems cannot measure temperature, right? Technically, what can you measure in an electrical system? There are only three things you can measure in a you can measure current, voltage, and if you can measure temperature, if you can measure voltage and current, you always know what the impedance is. So the three things you can measure is voltage, current, and frequency. Not impedance. Frequency or time. Okay. So here you can always measure temperature as a change in voltage and pass it to your. So this error, when does the system stop? When this error is 0, right? When your output temperature is the same as your input. Whatever input you are desiring, if that is 0, it will stop. So this is a closed loop system. You're feeding back the temperature of the room. Now think about a toaster. Toaster is a control system, right? It is not sending a signal back. It is just time based, right? So that's a open loop system. You're not feeding back anything. If you were to feed back, let's say, the color of the toast or how well the bread is toasted, then it could be a closed loop system. The ACs in your cars are open loop systems. Yes, most cars, they don't shut off. They're just constantly throwing off air. Some of the modern ones could be closed loops, but yeah, some of the new ones could be closed loop, but most of the car ACs. Okay. All right. So in all these cases, your question would be, what is the equivalent transfer function? You're always be asked. So you need to reduce the block diagram. Okay. We'll take an example. We'll take a look at an example, okay, of a block diagram reduction. See, whenever you have something like this is my error signal. If you have, when you try to identify systems and signals here, okay, whatever these lines are all signals, okay, and these blocks are systems. When a signal goes through a system, it changes, right? So the signal, this signal is C of S. When this signal goes through this H of S, this is something else, right? You can name that signal, correct? Similarly, this signal is a combination of these two signals. So you can name it. I just wanted to name it error signal, so I denoted E of S. Error signal is because this is my input and this is my output. I'm measuring this, what needs to go in and what is the output. If my output is the same as input, if I've already achieved the temperature, this E of S will be 0 and the system will shut down. Okay. You have to always understand signals and systems. signal goes through a system, it changes its form. It is another signal. You cannot name it. You cannot name the signal coming out of this as C of S unless H of S is 1. Or closed loop systems or feedback systems. So for example, your aircrafts, your spacecrafts, a lot of they cannot be open loop systems, right? Say that again. If a human is involved, it could be an open loop system. Because human acts as the closes the loop. For example, all your gliders are open loop systems. There is no feedback going because first of all, there is no control system in a glider, right? It's all actuators. You are the control system. If you have ever flown a glider, you are controlling it. You know there is some feedback in the form of altitude, in the form of there's some. You decipher the information and then move your controls. In a control system, that human is replaced by an actual automatic control system. This is automatic control system, right? An autopilot could be a closed loop system. Even a non-autopilot, if it's a semi-autopilot, a lot of your feedback is going in because, see, you cannot, for example, there is high frequency noise which is going to cause that disturbance in your wings. Now those don't get to your actuator. You cannot do that, right, when it is doing that. So those are taken care by a system inside your aircraft. It will just ignore those. It will ignore those disturbances. Okay. So let's take a look at an example. You're done with this? Huh? It's not an error system, it's an error signal. Yeah. Error signal, it's just a way of denoting. See, when you're controlling, what are you controlling? You need to know what are you controlling, right? You're essentially controlling that error. You are making sure that error is 0. That is how you're ensuring that the system is stable or doing what you want it to do. So you need that error signal. So let's take a look at this system. We have So you'll be given a system like this, okay? And you'll be asked, be asked to reduce this block diagram and derive the equivalent transfer function. Okay, so you have minus plus minus, minus plus minus. All these are pluses. Okay. These arrows are also important actually. It tells you, see, an arrow here does not make sense, right? Here. It shouldn't make sense because it's the same signal. Okay. I'm not going to deduct points, but it's a logical way of representing. You will know what your signals and systems are by just figuring out where those arrows are going. No. So this is your system. The first one you're going to do here is, if you're given such a system, so this, look at this. You can cascade this, right? Correct? So what you're going to do is, we're going to do G1 of S. You're going to replace all the summation signs by just one summation sign, and then you're going to do a cascade. So what is this cascade here? What is the equivalent cascade here? G2, S, G3S, right? And then you're going to have H1 of S, H2 of S, and minus, plus, minus. Okay. See, I haven't changed anything, right? The reason we did this was, so now you have G1 of S, and you can do this. Huh? This is the same as this one. I haven't changed anything. Okay. So here, what I can do is, I can do H1 of S minus H2 of S plus H3 of S, and this. This would be minus and this would be plus. Okay. So I combined these three. Right? For example, if you look at this signal, if you name this as error signal, okay? So what is your error signal? Error signal would be this signal minus H3 plus H2 minus H3, right? That would be your error signal. So what I've done is I've just kept the minus sign here and combined or added the other signals. So it would again be this signal, I have not changed this signal, minus H1 plus H2 minus H3. Okay? So let's look at it. So I'm going to name this signal here, the signal coming out of this one as x1 of s, okay? The signal R is coming out of G1 of s. I'm naming that as x1 of s. So what is E of s? E of s is x1 of s minus h1 of s plus h2 of s minus h3 of s, right? You agree, correct? This is the same thing. So this is still x of s, right? Or x1 of s, right? This has not changed. And if I use the minus term on these, it will just add. So this error signal will remain the same. Okay. Now you're looking at x1 of s into c of s. So this is a feedback system. You see that x1 of s, c of s. C of s over x1 of s is equal to what? G2 of s, G3 of s over 1 plus, since there's a minus over there, G2 of s, G3 of s into H1 of s minus H2 of s plus H3 of s. Okay. So I can write my G1 of s So what is your, ultimately what is your R of s over C of s? It's fairly simple. These two just cascade, right? These two systems. So all you're going to get is R of s I just introduced another signal out here. X1 of s is what? R of s into G of s. That's it. I was trying to demonstrate what E of s is. Okay. So you have G1 of s, G2 of s, G3 of s over 1 plus G2 of s, G3 of s into H1 of s minus H2 of s plus H3 of s. Okay. So this is your C of s. This is C of s over R of s. Or what is this? We represent this signal by T of s. Closed loop transfer function. G of s is generally used to represent open loop transfer function. T of s is used to represent closed loop transfer function. Okay. So you'll be given such a block diagram reduction in your exam, and you need to go through, even in your assignments, you need to go through this and figure out what this is called the equivalent transfer function. You see the equivalent transfer function, right? Look at what we started with and what we arrived at. So think about this as, see, these could be your various transducers. You know what a transducer is? What is a transducer? So transducer transduces signal. For example, transformers amplify. They step up or step down the voltages, and transducers, either amplifier is one kind of transducer. It just amplifies the signal. For example, your temperature. Your temperature can be transduced into a voltage or a current, right? The smell can be transduced into a voltage or current. Colors can be transduced into voltage or current. Transduce is transforming one signal to another. Or you look at something which is, electrical systems understand only voltage, current and impedance, right? Now, there are other signals though. For example, sight, light. You need something to transduce those signals or change those signals which can be understood by an electrical system. So you introduce something called a transducer. And these are all essentially transducers, or you can call them just sensors, okay? Feedback systems. Sensors are essentially transducers. This one? So this one, I'm looking at this. This is my feedback system, right? So what is the feedback system? What is the equivalent transfer function for the feedback system? It is G of S, the forward loop, over 1. If it's a minus, there's a minus here, correct? If it's a minus, we have plus, 1 plus forward loop into the feedback loop, the feedback element, forward element into feedback element. So the forward element is G2, G3, okay? This will always be given to you, okay? Your exams will be, midterm exams will be on 16th, okay? Yes, it will be comprehensive. The focus will be on the material covered since the midterm, but it will be comprehensive.